Well, just like before, we had a calculator that helped us do a bunch of stuff. The next one was substitution method, which helped us do a bunch of stuff. But now the last method that we want to do is something called elimination method. And it's a really interesting strategy. What you're going to do is you're going to add and subtract equations to get rid of either an x or a y. How do you do that? Well, step one says, okay, look at them. If necessary, multiply equations by a constant to obtain coefficients for x and y that are identical. What does that mean? Well, if one has a 2x and the other one has an x, multiply this entire equation by 2. And that way it becomes 2x, and guess what? They're the same, and you'll eventually cancel it. You're probably not getting that at this point. You will see in the next one. Then all you have to do is add and subtract to eliminate it. This gives you, guess what? Since you've eliminated one of the variables, so in this case I eliminated the x up here, I'll end up getting a y equals 2. And then guess what? Same. You go back to step 4, which means take this y equals 2, go back to the original question, and find my x values. Well, how do I do that? It sounds so great and so wonderful. Prove it. Okay, here we go. I'll prove it. Look at this. It says solve using the elimination method. First thing I want to show to you is this. This is, guess what? X's. And look how they're beautifully lined up here. This is Y's. Look how they're beautifully lined up here. There's the equal sign, and the numbers are lined up here. So you have to, that's the thing about elimination method. You have to have your X, then your Y, and then your number. An X, and then a Y, and then a number. If they're lined up, it's lined up perfectly for elimination. And I also want to show you something incredibly cool here. The cool thing is this. Check this out. This is going to freak you out. This is a 2y. This is a minus 2y. So guess what happens? I'm going to add these two equations together. Yup, I'm going to add them this way. So look, you got a 3x plus a 5x, which gives me 8x. But watch what happens when I add these two guys up. I've got a positive 2y and a negative 2y. And guess what? Goodbye. They're gone. Because if you add a positive 2y and a negative 2y, that gives you 0. That equals to, now look, there is a 19. You're going to add 5 to this. That's going to give you 24, which gives you, look how pretty. You're left with just an x. Awesome. To solve that, piece of cake. Divide by 8, divide by 8. X equals to 3. And holy smokes, look how fast and efficient that was. I think actually I like the elimination method the best. And one of the reasons why I like it the best is it's just so quick and efficient. I don't have to solve for y and substitute things back in. But do I ever give up on my substitution? No, because look, all I've got here is an x. I don't have the y yet. So I got to take this guy and substitute either back into this one or this one. I'm going to choose this one. Why? Because I think 19 is an ugly number. I'm going to look at this one because it's got simpler numbers. So look, 5x minus 2y equals to 5. My x is 3. I'm going to put that in right here. 5 times 3 minus 2y equals to 5. 5 times 3 is 15 minus 2y equals to 5. Look at this. Subtract 15 from both sides. That cancels, leaving me with minus 2y equals to minus 10. Divide by minus 2, divide by minus 2. I got y equals to, look at this, a pretty number of 5. So awesome. I've got my solution here to be 3, 5. Now, you can go out and you can verify this using technology. Absolutely. But the problem with that is you'd have to convert each one of these to y equals 2. Well, guess what? Question asks us to do so, so we're going to end up doing it. But let's see if we actually get 3, 5 as an answer. So I'm going to take this first question here. I'm going to solve it in terms of y equals 2. So here's 3x plus 2y equals to 19. Get rid of the 3y from both sides, or 3x from both sides. That's gone, leaving me 2y equals to minus 3x. plus 19, divide by 2, and look what I've got. I've got y equals to minus 3 over 2x plus 19 over 2. Could you imagine substituting that ugly equation into this guy up here? Gosh, that would be all fractions and it would just be terrible, wouldn't it? Yes, yes it would. Now, look at this guy. Let's solve that for y equals 2, because in order to put it in the calculator, remember, there's your y1. We now need our y2. All right, so 5x minus 2y equals to 5. I'm going to subtract the 5x from both sides. That's going to give me minus 2y equals to minus 5x plus 5. Divide again by minus 2. Oh my goodness, this just gets uglier and uglier and uglier every time I look at it. Minus minus gives you a positive 5 over 2x. 5 and minus 2 gives me a minus 5 over 2. There's our two equations that we're going to substitute in. So there's my calculator. Let's substitute those things in right now. So here's our first value, which is minus bracket, don't forget the bracket, minus 3 divided by 2, bracket x plus 19 over 2, 19 divided by 2. Oh, should have put brackets on that one as well. So let's clear that. Let's delete that, delete that, delete that, delete that. Okay, plus bracket 19 divided by 2, put the bracket. Then comes the next one, which of course is 5 over 2. So there's our bracket, 5 divided by 2. I didn't forget this time. X, okay, minus 5 over 2. There's another bracket, 5 divided by 2. There's our bracket. Look how ugly that is. That's incredibly ugly. Graph it. Let's see what we get. Okay, there's our one. There's our other. Let's do our second calc. Let's find the intersect, which is 5. Mouse this pretty close. Come on. Let's go. There it is. Enter, enter, enter. And I get exactly what I got as an answer doing it algebraically. 3, 5. So the advantage of doing this algebraically is you don't have to solve for y equals 2. The elimination method, I think, is quick and efficient.